Good afternoon, everyone. So thanks, Anupama, for the introduction. So in this session, we will be covering some of the areas that we have done recently in the integration space, some of the improvements that we have done to our products. And so we would like to make it a hands-on session and a very casual session. We can not a presentation type of thing, but a discussion. We can discuss the different aspects, and also your feedback is also very valued. So in morning session, Shankar discussed about our integration product portfolio and the capabilities of those products. So in this session, we will be diving deep into those things and do some hands-on sessions on that. So, okay. So this is our integration product as we had in our morning session. We call it WSO2 Integrator. So overall, it basically addresses all problems in the integration space. Right? So we can define, we can categorize those problems into multiple areas like automations, integrations as APIs, event-based integrations, file-based integrations, and also the latest thing, AI agents. So what are these? So automations are mainly timer-triggered integrations or manually triggered integrations. So let's say that we have two systems, let's say that we have Salesforce in one side and we have SAP as our ERP system. And periodically we want to synchronize sales orders between these two systems. In such scenarios, we can configure automation that runs, for example, daily and do the synchronization. These type of things are called automations. Then integrations as APIs, this is what we mainly familiar with. So these are, in most cases, REST APIs, where external systems can call these APIs, and as a result of that, it runs an integration and do certain tasks. Then event-based integrations are things like, let's say that we want to listen for a message from a message queue like Kafka or RabbitMQ. And whenever a message arrives, we have to do some work to handle that message. So as a result of that message, we may want to interact with multiple systems and do certain things. So that type of things are event-based integrations. Then file-based integrations are basically we are listening in a folder for a file. So that could be a local file system or shared file system or a FTP-based system. And whenever a file appears, we have to do some work on that file as a result of that file. So one common example could be, let's say in B2B communications, we work with EDI files. So we listen for an EDI file, and whenever an EDI file is present, we get that file and do certain things based on the data in that file. So these type of things are file-based integrations. Then AI agents is the latest thing where we can configure AI agents by pointing out different endpoints which can be considered as tools, and then we can give the prompts so that agent will use these tools as necessary and do certain tasks. So Anupama will cover those things in more detail, the AI agents part. So our integration product portfolio mainly aims to cover all those integration categories to give the very comprehensive integration experience. So in terms of development, again, we have done many improvements to our development experience. So we have basically done all our editors. We have moved those to VS Code based editors. Now all our integration products, the Ballerina integrator and the streaming the Micro Integrator, has VS Code based editors which are very user friendly, and you can just create integration flows just by using the graphical prompt. And also these accompany with AI assisted development, so that you can just give the prompt and do the development. So that again Anupama will cover in her session, how we can do AI assisted development just by giving the prompt. Then data mapping again is a very critical part in integrations. So whenever we go to a real integration, we come up with very complex data structures with multiple levels. So in that case, the mapping between these data structures is a hard problem that we have to solve. So in this area, again, we can use AI, and we provide AI-assisted data mapping to tackle these challenges. Then this is a very critical advantage of our platform. There is this pro-code and low-code development. So as I mentioned earlier, anyone can develop integrations in our product portfolio using low-code mode and also with AI. But the advantage is that for each of this development, the code is generated in the background. And if you're using Ballerina Integrator, the generated code will be a Ballerina program. So it is a fully fledged programming language with all the features that are available in any other programming language like Java or Go, so that you can just edit the code as well, and then the diagram will change accordingly. So this is a very valuable advantage when it comes to writing complex integrations, because when the integration gets complex, usually we have to switch to code mode for some certain tasks, and it is easier to do that in code mode. And in that case, this comes in very handy, because we can just switch whenever necessary and then switch back to the low code mode again. Okay, so then our integration products come with a large number of pre-built connectors to connect with different protocols such as HTTP, gRPC, WebSockets, and so on, as well as to connect with different systems, like for example, Google Sheets, SAP, Salesforce, like all those systems, we have connectors so that we can simply use those connectors and use the methods available in those connectors to connect with those systems. So this is an area that Anupama will cover. So basically, as I mentioned, we can build AI agents using our products. So what we do there is basically we give the endpoints that the agent can invoke, and then we can give the prompt. So then agent will decide which endpoints to invoke for certain tasks and then do the integration automatically. So that part will be covered in more detail in the Anupama session. Okay, so then, so that is about the development experience. Then when it comes to enterprise integrations, monitoring and management is a crucial thing that we have to do. Right? So when it comes to monitoring and management, there are two things. One is that we can monitor the enterprise integration itself, and then also we can monitor the messages that are flowing through those. So with that, we can get an understanding about how our business works. So there are two aspects. First is the infrastructure level monitoring of the application, then the monitoring of the business activities that are happening through our integration platform. So all those things can be monitored and managed by the tools that we provide with our integration platform. So then when it comes to architectural styles, so there are two main architecture types that we support, so that are mainly used in the industry. First is actually the centralized architecture, which was there for a certain period of time. So there basically we deploy the integration platform as a central component, and all our applications and backend systems connect to that centralized system, and all the integration logic is developed within the centralized ESB. So that part we support with our platform, and also we support the other style, which is the microservices style. There we can componentize integrations into multiple components and deploy those integrations independently. So that is the main thing here. That is the ability to deploy these things independently so that we can manage and scale those integrations independently. So the point here is that, let's say that we have different teams in our organization that are developing integrations. Like, for example, we have the sales team, we have the engineering team, you could have the marketing team. So those different business units may have different integrations that they need. Now they develop these integrations, but if we have the centralized architecture, then we have to deploy those into the same centralized ESB so that the governance structure applies to all those things. But that basically reduces the flexibility. But if we go with the microservices style, then they have their own integrator. So they can just deploy that integrations into their own integrator and they can manage the deployment. So that flexibility is there in the microservices deployment. So both these styles are supported in our platform. Then deployment options. So this is like very valuable thing that in our platform, that is the deployment flexibility. So our integration platform can be deployed on-premise and on cloud, and also we can support hybrid deployments. So on-premise means we have on-premise software that can be deployed in your own data center, or you can deploy that in your own cloud account. Then we also have cloud deployments, which are managed cloud deployments, which are managed by WSO2 for you. So you can treat those as SaaS products because you don't involve in the management of those deployments. Then hybrid mode is also supported. That means, let's say that you have certain applications that have restricted access to outside. So in that case, if you want to integrate those applications, you can deploy integration components within your data center closer to those restricted applications and do the integration there. Then you may have certain parts of your integrations that needs to be there and should be accessible to wide audience. Those parts can be deployed on cloud. Then you can communicate between the cloud component and the on-prem component between the integration platform. So that flexibility is there. So you can decide how to deploy, and if you want, you can mix the deployments as well. Then we also have an integration cloud, which is called Devant. So that is basically a SaaS platform. You can develop your integration. The same integration that you deploy in on-prem software can be deployed in this iPaaS system as well. So this deployment flexibility, usually many other vendors don't provide this type of flexibility when it comes to deployment. So that will be an advantage in this platform. So this is how we use, this is an overall diagram about the iPaaS system that we provide, which is called Devant. So there we have the control plane, which basically you can use to design, develop, test, and deploy these integrations. So I think Anupama will cover this part in detail. So then with this same control plane, you can have multiple data planes. So these data planes can be in any cloud provider, or that they can be in your own data center as well. So these all integration data planes can be managed by a single cloud-based Devant control plane. Okay. So these are the components of our integration platform. So we have different integrators. First is the WSO2 Micro Integrator. So like that has been there for a while, for many years actually. So that part, with that we support low-code development as well as centralized deployment as well. Then we have the Ballerina integrator, which is the new member of the family. So it is a low-code experience built on top of Ballerina programming language. So I will be covering that in detail within this session. Then we also have streaming integrator, which can be used for streaming integration scenarios. For example, let's say that you are receiving certain set of events from an event stream. For example, let's say from a Kafka topic, you are getting a set of events, and then you want to aggregate these events for a certain time period, and you want to calculate the sum or average of certain value. So if you want to do such cases, then you can use WSO2 Streaming Integrator. Then all these three products can work in collaboration, and you can decide which one to use when. Right? So for example, if you have a streaming case, then you can use the streaming integrator to receive the events and maybe do some aggregations. And then you can pump those events to the Ballerina integrator. And there you can connect that with certain other systems and build your integration. So you can, like that, you can mix and match these components as needed. Then we have WSO2 integration control plane, which is the management layer for all these integrators. So with that, you can monitor the health of these different integration nodes and what are the artifacts deployed in these nodes and how these artifacts behave. All those things can be monitored by the control plane. Then you have the Devant, which is the iPaaS system. So all the integrations that you develop and deploy into these integrators can be deployed in Devant iPaaS as well. Right? Then in addition to that, we provide monitoring capability or the analytics capability based on the OpenSearch-based analytics product that we develop. So that is the product portfolio of the WSO2 integration platform. So if you have any questions, you can ask. Okay. So now we can move to the integration lab, which is sort of a hands-on session. So let's first discuss about the use case that we are going to do. So we have taken a very common use case, which is sales order processing. So these are the components that are involved in this. So we have our end user systems, which can be web apps, mobile applications, and also can be partner systems, which want to place orders, basically. Let's say that we are building this for a retail company. So the customers of this company will use this system to place orders. So these orders are handled by the sales order handling service. Then we have a set of backend systems. So we have a customer database, inventory system, purchasing service, finance service, and shipment handling service. Okay. Then, we also have a wrapper around inventory system and purchasing service to handle inventory reservations according to our requirements. So this is our overall scenario. Now, in terms of the implementation, we use Ballerina integrator to implement the sales order handling service, and we use the Micro Integrator to implement the inventory reservations API. So this is the scenario that we are going to do in this session. So all these backend systems, we have make those available as a Git repo. So if you want to try out, you can check that out and run it. So if you need that, we can provide the link. So let me check. So this is the backend system. Is there a way to share this? Sorry? For this, haven't done that. Anupama, can you try to? Okay, Anupama will look into that. So until she does that, we can continue on the development. Okay. So we will first try to implement the inventory reservations API using the Micro Integrator. So before going into that, like anyone who has used Micro Integrator before? Any customers of Micro Integrator? Okay, we have it, right? So which version have you used? Is it the latest one or which develop? Sorry? 4.2. Is that with VS Code or the Integration Studio?
We use
VS Code, okay. So then it will be the same experience, but we have improved upon that. So this is the scenario that we are going to implement for the inventory reservations API. So we create an API with this path, and this API will receive a payload like this. And when the payload is received, it will try to call the inventory system, which is a backend service, to allocate the items. And if the allocation is successful, it will respond with this response. And if it is not successful, it will call the purchasing service to order items, and then it will respond with this status. So this is the flow that we are going to create. So let's switch to VS Code. So I'll create a new project. So this is the Micro Integrator plugin for VS Code. So there I am going to create a new project. Now I can give the project name. So let's call it, let's say, ABC Mart. So this is our retail store's name. Then we have to select the location for this project. So I'll select this. So I selected a folder for the project. Now that's it, right? So then I can just create the project. Okay. Now we can see different integrations that we can create. So as we discussed earlier, we can create API-based integrations, automations, event integrations. And there are many other things that we can create. Right, we will come to some of these things. But for this part, we will start with the API integration because as we saw here, our target is to create this API, inventory/reservations API. So let's create an API. So we have to give the name for the API. So let's call it inventory. So we can keep these things as it is. So it will automatically put the context or the base path of the API as inventory. So we can keep it. So let's create the API. Now it will create a single method for the API, but we can change it if needed. So let's go back and. Okay. So we want this to be a post method with the path reservations. So let's change it like that. Shall it? No, you should be. But I had to open WhatsApp. So here we can select the methods that we want to support. So in this case, we only need to support the post method. So I click on that. Then our resource path will be reservations. Right? So if you want to have a path parameter, like say example, we want to have a path like reservation / some product name or something, then we can add a path parameter here. Also, we can add query parameters to this if needed. But in our case, we just need the reservations path without any parameters, so we keep it as it is. Okay. Now we updated that, so you can see that now we have a post method with the path reservations. Now we want to implement the integration for this path. For that, we can simply click on this and go to the implementation part. So here we can keep on putting different integration constructs to build our integration flow. So one thing I will do first is to give a sample payload. That means we can associate a sample payload with the start event so that it will be used within other constructs. For example, in this case, we know that our payload will be this one. So we can add that as the sample payload. Let's call it sample1. So we add that payload there. Now, so we want to get the values of this payload, and we may need to access these different payload components like order, product, and amount within different integration constructs. So to do that, we can create variables out of these payload fields. So that's what I'm going to do now. So I'm going to create variables. So first variable will be order ID. The data type will be string. Then for value, I can give a literal value, or I can give an expression. So in this case, I am given an expression. And for the expression, I have the option of choosing the values from the payload, variables, headers, and so on. So in this case, I want to select the value from payload. So I click on that. Now it will get the sample payload I gave to the start event. And from that, it shows the available fields. So here, the order ID variable should contain the order value. So I click on that. I am done. So I create the variable for the order ID. So similarly, I am creating variables for other fields as well. So one would be product ID. So for that, I want to extract the product field from the input payload. Then the third one would be the quantity. So this data type of this will be an integer. And the value we have to extract from the payload, which is the amount. Okay, now I'm done with extracting values. Now we can simply check the flow up to this point. So let's put a log statement as well. So in this log statement, let's say I want to log the variable order ID. And I want to simply respond. So I just complete the flow up to that point, then I can just run it and test. Okay, now it is started. Now it shows the available methods here. So this is the API that we just created. So I can try it here. Okay, I want to try this out. So I give the payload from here. execute. So you can see the order ID, which is A100, is logged here in the bottom of the screen. So that is the log mediator that we added. So if you go to the response, you can see the input is given as the response because we just respond without doing anything to the payload. Okay. Now we want to invoke the inventory backend. So if you run that GitHub Ballerina program that I have given, you will get this endpoint. So this is the inventory endpoint. I hope you can see this. Let's try to do this. Okay. So this is the URL, and the payload would be this. Right? So we have to give the order ID, product ID, and the quantity to the allocations API. So let's invoke that within the integration flow. So to invoke an endpoint, we can use the call mediator. So put that one, and then we have to give the endpoint. So this will be a HTTP endpoint. Let's call it the inventory endpoint. And the URL is the one I copied from there. And the HTTP method is post. Right? Okay, I create that and I can add it. Now you can see that the call mediator is added with that points to the endpoint, inventory endpoint. Right? So with that, we simply call this endpoint, but we want to change the payload that is going to this inventory endpoint because our input payload is this one, which contains fields order, product, and amount. And for the inventory endpoint, the fields will be order ID, product ID, and quantity. So those field names are different. So we have to reconstruct the payload before invoking this endpoint. So to do that, I can use the payload mediator. And here I can give the new payload that I need. So this is the payload I need. Now again, for that also I can get the values as expressions. So we extracted the values earlier as variables, so I can simply give those variables here. Order ID will be this. Product ID will be the product ID variable. Oops. And the quantity is the quantity variable that we have. Okay, now we are done creating the payload for the inventory endpoint. Now we can simply run this and test at this point as well. So let's run this. So I'll be using Postman to test this without using this generated one. So if I give this, now it will invoke the inventory service, and from that we get this response. Right? Then, so now the next part is, if the allocation request is successful, we have to give this response, and if it is not, we have to call this service and give this response. Now, we can check whether the allocation request is successful based on the result. So let's say that if we invoke this, so if it is not successful, we get the status as out of stock. And so we have to so if it is successful, we will get the status as allocated. So now after calling that inventory service, we have to check the response and the status field of the response. And based on the value of that status field, we have to decide how to respond to the user. So let's go to our integration and put that part. So to do that, we can use the if-else mediator. So there we can give the condition. So condition in this case will be the payload again. So from the payload, we have to get the status field. And if the status field is equal to allocated, then we can respond with the success result. So this is the flow that is created after that. Then at this point, we can create a payload with the success result and respond. So again, I can give the payload anything here. So this will be again an expression that I have to extract from the variable that I defined. Or the ID will be this one. Okay. So likewise, we can keep on building the flow. So now we create the payload and then we can respond. So likewise, we can build the rest of the path here. So here, the path will be similar, like we have to build the payload for the purchasing service and then call that. For that, again, we can have an endpoint. So I will quickly show how we can add an endpoint and invoke that and how the diagram changes after that. So purchasing service will be this one. So we'll add the call mediator here. We add a new endpoint, and let's call it the purchasing endpoint. And the URL is the one that I just copied. It will be post, create, add. Right? So that's it. Now we basically call the purchasing endpoint from this. But again, we have to change the payload. For that, again, we can use the payload mediator and create the payload. So I'm not going into the details of all these things, so it will be the same flow that we are doing there. So that is the development of the inventory API using the Micro Integrator with the latest VS Code extension. So I will any questions up to that? Yeah.
Show the source code underneath.
Yeah, we can. Yeah. So with this sign up here, we can switch to the source code. So this is so here, this Micro Integrator is not based on Ballerina, so it is based on the Synapse language. So the source code will be the Synapse XML based source code, this one. In the next one, I will show the generated Ballerina code when I use the Ballerina integrator.
But even here, if you change something on the source code level, it might not impact the graphical change will still be made, right?
No, it will change the graphical view as well. If I do something here.
For instance, if you change the variable, for instance, it's 10, it's now 11, it won't show up in the graphical overview.
So
There's only a high level.
yeah. So we can't see the details here. Yeah. But like if we change something here, and let's say now if we change this to, again, let's say order here. Okay. Now this high level one, we can't see it. But if I click on this, you can see now it is changed to order here. Right? So basically the graphical view and the code view are the same. So we can click on that and go into the details. Then we see the exact thing there. So that is the micro integrator. Yeah.
This works with the enterprise integrator, the latest version as well?
Yes. Latest version, that is Micro Integrator 4.4, the latest one.
But the enterprise integrator, the 7.1?
No, actually. So Enterprise Integrator is the previous version, and the latest one we call it as the Micro Integrator. So basically, yeah.
The latest version of enterprise integrator implements micro integrator inside.
Yeah, so
But the enterprise integrator actually supports integration studio. So one of the latest version of micro integrator, which is for post series, will support VS Code. So to use these features in VS Code, we have to use micro integrator. That's all.
Thank you.
To have this feature. Right now we don't have that because integration studio is very but not with this much of flexibility. So enterprise integrator, as of now, we are going with integration studio. We are not planning to backport any of these things to previous versions. So we expect customers who might face these versions if they are still developing these because we need this more if they are still in the development cycles. So in that case, I will try to have this together with the integrator supports this.
I think as to the enterprise integrator version of the product, the integration product, is internalized now. The latest version is micro integrator, but for customers who are still using enterprise integrator, we still provide support for that. And we don't backport people, so we do support whatever existing requirements they have. But the newer versions of the product will be micro integrator version 4.2 onwards. And then Ballerina Integrator version 1, which was released today, that's another software component as well that we have, which I think Anupama is going to showcase later. So the new versions of integration stack on the software side will be new versions of Micro Integrator and new versions of Ballerina Integrator.
So
Well, we'll keep both. Yeah. So we are going to, because Micro Integrator, we have over 300 customers using Micro Integrator as well today, right? So that's going to be a key aspect of our product stack going forward as well. So both Ballerina Integrator, Micro Integrator, Devant, and Streaming Integrator will have an equal status in our product stack, integration product stack going forward. It's just that they address different customer requirements. So it depends on what each customer is looking for.
It looked like Synapse code. So if I were to run it on 4.1 or 4.2, would it work, or is there an addition to the Synapse core being made in 4.4? Because I think I saw some stuff that I haven't seen before.
which one, like variables you mean?
Yeah.
Yeah, variables we have introduced late for the later versions.
Okay, so that's only going to run on 4.4, not on previous versions.
Yeah.
Okay.
A more general question. Have you tried Cursor on top of this Visual Studio as well?
So at the moment we have decided to go with VS Code. So yeah, we might consider, like, Anupama, do you want to comment?
The thing is, like in WSO2 Integrator product stack, we decided our official tooling is going to be VS Code. So as of now, we don't have anything to any other plans to support other editors. Because even Micro Integrator, Ballerina Integrator, all of them are supporting VS Code. With the graphical support and everything, we are continuing to evolve all these plugin capabilities, but we don't have a plan to extend to other editors. When it comes to Ballerina, which is underneath language of the Ballerina Integrator, we can use the visual without visual editors on those plugins, but that is also in the roadmap. As of now, we are officially supporting VS Code plugins because it comes with all the visual capabilities and other connectivity between WSO2 Integrator, Ballerina Integrator, integration control plane, Devant, all the deployment options. You can configure all of them here. So with all these connectivities, we are going it as official tooling support.
Okay. So I'll quickly demonstrate one more thing. So that is the Ballerina mediator support. So as I'm going to discuss in the next part, so Ballerina is integration-oriented programming language developed by WSO2. So with that, it is very easier to do integration-related stuff like handling JSON messages, calling HTTP endpoints, and parallel processing. All those things are very easy to do with Ballerina. So therefore, when it comes to complex logic that needs to be embedded inside integrations, so it is easier to use Ballerina for that purpose, even within Micro Integrator as well. So to support that use case, we have introduced Ballerina mediator. So let's say that I want to add some Ballerina code in between, let's say, calling this service and this if statement. So in that case, what I want to do is I will first create a Ballerina module. So I will go to mi add artifact. And here you can see there's a Ballerina module artifact that I can create. So I can give a module. So let's say that I want to validate the inventory request. So let's call it inventory validator. So let's assume that we have some complex validation logic that we want to implement here. So I'll give a version for this, and then I create the module. And then you can see that it is a Ballerina code that is created here. So I can write any Ballerina code here. So let's call this method validate request. And request in this case, let's say that what we get is a JSON message. So as you can see that JSON is a native type supported within Ballerina. And so let's say that I want to return a JSON type as well. Then I can in between write any complex logic to process this JSON. But in this case, let's say that I want to just print it. And I can simply return some JSON value. So because JSON is a native type in Ballerina, I can simply create JSON messages like this. I type in the curly brackets, and then I can type anything here, status, and then I can access available variables. So let's say in this case, just I put a string here. So likewise, like if I want, I can create a type to store this inventory request and then map this incoming data to that type natively. So I can do all those things that are supported in Ballerina to process this message. Now I do this, and then I can make this a Ballerina module, and within my integration flow, I can invoke these messages. So at the moment, I think I have some problem in this, my installation. So yeah, I'm not going to show details there. So this type of integrating Ballerina within MI is possible with the latest release. So with that, I think he can move to the next part, which is the Ballerina integrator. Yeah.
What about handle the logs? Actually, how to handle then logging in this scenario if you are using Ballerina, for example?
Yeah, in Ballerina also there's a logging module. So if I go here, so there's a log module. See, so with that with this I can put anything. So it will be captured in the same log.
So I assume even the debugging will be the same, right? When you are running how to debug then the full flow, for example?
So debugging within the Ballerina module, I'm not sure whether we have done that. So we can debug, of course, the MI flow, but when there's a Ballerina module, so I have to check how we can go inside that. So I haven't covered that yet. Okay, any other questions?
The micro integrator APIs were created. Is it stateful or is it stateless?
So that depends on how you implement it actually. So usually it is stateless, but if you call a database or store something in the database, then it will become stateless naturally. But usually it is a REST API without a state.
Because the problem comes while error handling, right? Because when you are calling multiple APIs, and if one API call fails, and then how to do proper handling is a bit of a challenge. How do you address those kind of scenarios? Or
I didn't get your question.
let's say you are taking some decisions in the flow, right? Calling an inventory management API, and if one of the API call fails, what happens to the next? Or we continuously keep retrying or maintain the state somewhere? What's the best practices around that?
Yeah, we can configure retry configurations and also suspension configurations for endpoints. So the endpoint itself, it's shared between among all the occurrences of the flow. So that means if one flow marks an endpoint as suspended, then other requests will not invoke that, because endpoint is basically shared. It's sort of a stateful thing. So there can be multiple calls to the API, and each call is handled separately. But if all those calls invoke the same endpoint, and if one point that endpoint is marked as suspended, then it will be marked suspended for all API calls.
Okay, but the preferred use case is stateless. That's I understand. Yeah. Good. Thank you.
Okay. So I'll move to the Ballerina integrator part. Okay. So I'll try to implement some part of this scenario, sales order handling service. I might not cover the whole thing in interest of time, but let's see how far we can go. So this is the scenario that I want to cover. So I want to implement this API, sales/orders, which is a post method. And this is the request payload that I am getting. And then once I get this payload, I want to invoke the customer database. Basically, I want to query the customer database and get the customer's address and whether the customer is blocked or not. If the customer is blocked, then I want to return a failure message. If he is not blocked, then I call the inventory API, the one we just created. And then we can call inventory processing API, invoice processing API, and the shipment handling API in parallel if you need. Right? Shipment handling API will be a file-based one. Basically, we want to write the payload to a file. Right? So this is the scenario that we are trying to implement here. So I will go to the VS Code and create a new integration. for the Ballerina integrator. Yep. So let's call this again ABC mart. So this is our integration name. And let's create the path for this. Okay, now I can create the integration. Okay. Now here you can see different integration artifacts that the Ballerina integrator uses. So we have entry points, so which are basically the integration types that we support, like APIs, automations, and so on. Then listeners is something bit technical, we don't want to cover it here, touch it here. Then connections are the connections to external systems that could be databases, HTTP services, or SAP system, Salesforce. All those things can be connections. Then types, because Ballerina is a typed language, which means that we can basically define data types to handle data, to store data. Right? For example, let's say that I am working with the customer data, then I can create a customer data type, so that the customer data that I get can be mapped into that data type. So we can have functions within Ballerina and call those functions within integrations. And also we can have data mappers where we can give JSON schemas or manually typed schemas and then map data between those schemas. So then we have configurations to store configurable values. For example, let's say that we are calling a database and we want to store the username and password of the database externally to the program. Then we can use configurations for that. And these configurations will be stored in a file. So let's say in a Kubernetes-based environment, we can view that as a config map to the program. So let's create an entry point for this. Let's go add the artifact, and in this case, I want to create a HTTP service. So you can see different things that we can create. So we can create GraphQL services, TCP services, and then for event integrations, we can have listeners for Kafka events and RabbitMQ. We can listen for a RabbitMQ queue or a topic. There are many things that we can do to trigger an integration in Ballerina integrator. So in this case, we will create a HTTP service. So we have to create a listener to attach a port with this. So let's create a new listener. So we can give the port to listen on. Okay, now we can give the path of base path of the service, which will be shop. Okay, now we create the service, and again we get a sync1 method automatically generated. Now you want to change this to a post method with the path orders. So let's do it here. Click on this, and the method is post. Path is orders. Right? Then we can associate a payload as well. So in this case, as I mentioned, we can create a data type to store our payload. So that's what I'm going to do now. So I know my payload is this one. This is the request that I'm getting, order, which contains order ID, customer, product ID, and quantity. So I want to create a data type to store this JSON message. So I go to payload and I want to add a payload. So I give a name for the payload, which will be, let's say, sales order. And for the type, if I have already defined it, I can select it here, but I haven't defined it yet. So I click on add type. And from here, I can define my data type. So let's call it sales order. And if I want, I can just manually add fields and create the data type. But I have the option of basically giving a JSON payload and automatically create the type for that. So I give this payload and I click on import, and it will automatically create the data type to store that payload. And I save it. Right? Then I can also have multiple response types, and for each response type I can have a data type as well. So I'm not going to give that at this point. So I save this. Okay. This. Okay. Now I can go on and create my flow. So the types I created, you can see it lists under the types section here. So if I click on that, you can see the sales order type is created. So you can see the fields and the types of these fields in the sales order type. So likewise, I can create any other types and use those types within my integrations. So let's say now for the first invocation, I want to invoke the database. So for the database, the response of the database will be the customer data. So let's say that I have already created a table. So this is my table. I think you can see it. I'm not sure that I can. No, I can't zoom it. So basically the fields of this table will be customer ID, address, and status. So I have to have a data type to store these fields. So let's create a new data type to store that. So let's create the data type as customer. Now let's create that manually because we don't have a payload for that. So the first one will be the customer ID, which will be a string. And the second one will be address. Again, it will be a string. The third one, again, string with status.
The format?
Which one?
Restricting the format of the string. Is it possible?
Format means the length or something? So yeah, we can have restrictions, like we can give a regex and like restrict the string. So we can do that. Yeah. So I create a type to store the response from the database. Now I can go ahead and invoke the database. So first thing that I do here is, now I want to invoke the database. First I have to create a connection to the database. So for that I can go here and add connection. So in this case I'm using MySQL database. So I search for the MySQL connector. So I get the MySQL client. From that I can give a name. So let's call it customer database. Okay. Then I can give other configurations. So in this case, host will be localhost, user is root. So password, again, I don't want to hard code. I want to use that as a configurable value. So if I want, I can just hard code here, but because of the security reasons, I want to use that as a configurable value. So I go to configurables and I create a new configurable. Okay, so name will be, let's say, db pass. And type is string. So if I want, I can give a default value, but in this case, I'm not giving it. So I save it. So I have a configurable called dbpass. Now if I go to connection, go to MySQL. Okay, so this I have to type in again. Now here, for the password, I can click on configurables and give the new configurable that I created. right? Okay, so database name in this case will be Gmart. Okay. So that's it. Now I created, configured the database connection. Now from this database connection, I can invoke different methods. Now in this case, I want to invoke a method, basically query, which returns a single result. So I choose this one. Okay. So the return variable name, let's call it customer. Okay. Now the return type. So we have already created the customer type. So let's search for that. Okay, why doesn't it? It should come. Oops. So let's keep it any data for now and give the query. Okay. Should be fine, right? Let's try it again. Okay. So I can give the SQL query that I want to execute here. And I can also incorporate variables into that. So in this case, I want to get the sales order. And the customer value of that one. It's customer ID. Okay. Type, I think it should come here, but there's some problem. Let's figure it out later. Okay, so ideally the return type, we should be able to give it as customer type that we just created. Okay. Okay, I think it's done now. Okay. Now, so we can simply print, let's say I want to print the customer address here or log the address. So let's go to login info and a message. As a message, I will simply get the customer value. So I have to switch to code. Now the customer variable is here. From this, I want to get the address. Right? Okay. So let's try to run this up to this point. So let's try to actually debug this and see how it works. So I add a breakpoint here. And now I run this, debug this basically. Okay, now what it is saying is that I have created a configurable value, but I haven't given that value in a file. So I have to create this config.toml file and give a value for the configurable value that I have created. So I choose to create it, and for this db pass configurable, I have to give a value. So the database password, I have to give it here. Now I can run this. Okay, now I am debugging the flow. Now if I send a request here, you can see that the debug point has hit. So at this point, we can see the variables. So this is the current execution point, and at this part, we can see the variables. So we have a variable called customer, so which is the result of this MySQL invocation. And if I expand that, I can see it has fetched values from the database, the customer ID, address, and the whether the customer is active or not. So these values are fetched from the database, so we can see it, and then we can also step through the integration. So we go to the next step, and then this will print the customer ID. Okay, not. So likewise, we can debug and watch the variables at each step. So that is the database invocation part. Now the second part, what we want to do is that if the customer is blocked, we want to return an error message. So for that, what we do here is we get a if-else statement. So we have the if control block. So the condition for this will be whether the customer is blocked. That means customer's status is blocked. So if this is the case, we want to return an error message. So to return an error message, we can simply use the return control here, and we can give the message. So as JSON is a native type within Ballerina Integrator, I can simply type in the JSON message here. So I will simply type something like status. Okay. So with that, I can close that. So now if the customer is blocked, we simply terminate the flow and return the error message. If the customer is not blocked, I want to invoke the inventory service. So basically inventory service is another HTTP service that is running outside. So to invoke that, we have to create a connection for that. So my inventory service is this one. So I create a HTTP client for that. So client name, let's call it inventory endpoint. So URL is the one that I just copied from there. Okay, so that's it. So actually, if I want to have a single endpoint and then invoke multiple methods with different paths, I have the option of just creating endpoint with this path and then have multiple invocations with different prefixes, postfixes. Okay, so I create the endpoint. Now I want to invoke it. So because it is a HTTP endpoint, I get the HTTP methods that I can call on that. So for this, I want to call a method, use the call post method. And the variable name here, so variable name is the return variable name. So when we call the HTTP function, HTTP call, it returns something, and that what is returned will be assigned to a variable. So this variable name is the name of the variable that assigns that result. So let's call it inventory result. And again, we can have a data type for this result. So if I invoke this inventory service, this is the result I get. So it contains the order ID and the status. So I want to create a data type to store this value. So I go here and under the target type, I select add type, and let's give the type name as inventory result. And I want to create that from the JSON message. So I create that from the JSON message and I can save it. So inventory result will be assigned here. Then path. So path is the last part of the endpoint, so which is allocations in this case. Okay, now I have to give the message. So message is the payload that I want to give. So in this case, the payload for this is this JSON message. So I can simply copy it and paste it here and fill the necessary parts with the expressions. Right? So this is the literal payload. Now I want to change these things. Basically the order ID you have to get from the input. So with that, I can simply invoke the inventory endpoint. Right? So if I now go to the architecture view, so there's something called architecture view, which basically shows how our integration looks in the overall view. So here we can see we have the shop service, and within that we have the post method with an operation orders. Then with that we connect two endpoints, customer database and the inventory endpoint. And if I click on this, I can go into the implementation and see how the integration flow goes. So this is basically the Ballerina integrator. And so there, if I switch to the code, you can see the generated Ballerina code. So this is again a fully fledged programming language with dedicated constructs for integration. For example, you have connections, for customer database, you can see this connect is created. And for inventory endpoint, we can see this connect is created. And then we handle JSON natively, and we can map JSON to types natively. So all those things are happening under the hood, and you can just go in and change it here, and it will update the diagram as well. Okay, so that is about Ballerina integrator. Any questions on that? Yeah.
Regarding can you show us the code again, please? I can see that do on fail, it's the try catch block, right?
Yes, this one. Yeah.
Yeah.
It's similar to try catch.
Yeah, but what we want to have another one inside it or somewhere else, how to do it? Multiple try catch block.
You want to nest this? Is that what you want?
Yeah, the try catch block instead of having this one, because this is not showing in the diagram, I think. This one is not showing in the diagram, right?
So it's shown here, right? So as the error handler.
Error handler. Okay, but this is for the full one. What if you want to have one for the database itself, another one for the full? Then you have to have that.
So you want to have another
Error handler
on fail block somewhere here? Is
for
it?
the database itself, for example, to handle database connection or connectivity or the service.
Mm-hmm. So basically, so this is one way of handling errors, but you can see that this check statement here. So that is basically we are saying that if there's an error, throw it. Right? So instead we can handle this here itself as well. So we can basically remove this and we can cache, like get the error here as well. Right?
Okay.
Then we can check whether there's an error and do anything there.
Because sometimes we are not, we are calling another API, for example, instead of database, we call another API service. So we want to have this error handler as well. The same?
Yeah, so we can do like error handling at any stage. So that's up to the developer.
Okay, good.
Okay. Any other questions? Okay. If there are no questions, I can maybe quickly show the monitoring aspects of this based on the OpenSearch based product that we have developed. Yeah, maybe. Yeah, sure. Yeah.
Hello.
Yeah.
So I know earlier in the presentation you talked about the data mapper and it having like AI built into it.
Yeah.
I'm wondering how is it built in and to what extent? Because to me, in like a traditional integration flow, I want to have everything deterministic. And I have a hard time figuring out how the AI would fit in if it should be deterministic. Is it that it helps you map the data and then the actual thing that gets put into your flow is deterministic? Or is it non-deterministic, e.g. it asks every time some LLM or something else? Like how does it work?
Yeah, so AI by definition is non-deterministic, right? So basically what we do is that we suggest certain things and basically developer can always change it as needed. So like if there are, let's say, hundreds of fields that we need to map, like it will like check the field names and types and so on, then try to come up with a mapping. And then developer can get that mapping as the base and then do any changes.
Okay, so it gives you an output which is then deterministic.
Yes.
Okay, thank you.
Anything else? Yeah.
Now what's about the, what do you call it? The documentation for the service, for example. If you want to, documentation. If you want to export it, then it will be the Swagger one or there is another format?
So we can generate the OpenAPI definition from this.
Okay. We can customize it as well or just generate directly, it will be giving us the Swagger document, I think, or OpenAPI.
Yeah, we can give the OpenAPI document and then generate the API if we need. So if we have the document, we can generate from that. So we can do the other way around as well. We can write the code and then from that we can generate. OpenAPI document. Does that answer your question? Yeah. Okay.
I hope you all can hear me well. So we are continuing with the second part of our integration tutorial today. First of all, whether you were here in the first part, I can see many familiar faces. You were here, most of you. But in case if you just joined the integration track, I'll give you a quick update on what we have covered so far, and then we can continue from there. So what we are covering today here in this integration lab is about WSO2 Integrator, which is having multiple parts in it or multiple components. So most familiar component here should be WSO2 Micro Integrator. I guess most of, or at least some of you are using WSO2 Micro Integrator. And the other components are Streaming Integrator and Ballerina Integrator. So each of these are having different capabilities and we are using it for different purposes. And what component we are going to use in our integration development it's depending on the familiarity of the technology or maybe the use case, how you are going to deploy it, many factors like that. So we can cover any questions if you have in that aspect once we are done with the sessions. And also on top of that, we have integration control plane, which is kind of the controlling agent which interacts with all of these things to make sure that we have a single controlling plane which can control the runtime aspects as well as logging, those kind of things. And finally, we have at the corner is the iPaaS. So we announced the Ballerina Integrator and the Devant. Both of these as new products during this conference. So those are the two new components. Micro Integrator, Streaming Integrator, and the Control Plane are already available products. Devant is our iPaaS offering, which is a new thing, and it works seamlessly with these components, especially Micro Integrator and the Ballerina Integrator, where most of our integration logics are at. So this is an overview of the integrator. So we are so in the first half of this session, my colleague Chathura has developed the integration use case. That is using Micro Integrator and the Ballerina Integrator. We developed part of it using Micro Integrator and part of it using Ballerina Integrator. The good story is like whether you are using Micro Integrator or Ballerina Integrator, we have a connector in between Ballerina Integrator and the Micro Integrator, so that if you are already using Micro Integrator and if you prefer to have Ballerina Integrator for some of these things, you can use that connector to write your logic in Ballerina and then bring back that into Micro Integrator. So that will work seamlessly. That means those are not very isolated components. You can use those as needed based on your team's capabilities, expertise, as well as the deployment architecture that you are thinking of. And also these components can work as in different ways, like Micro Integrator support ESP style deployment and Ballerina Integrator support microservices and centralized deployment patterns. Micro Integrator support microservices as well. Likewise, each of them have different deployment patterns, or it will cater your various scenarios. So it is up to the developers and the architecture team to decide what components to use. So that is what we are trying to touch a little bit during this tutorial, what to use and when to use, as well as some of the new features. So that is a kind of summary. I think Chathura covered a high-level overview of all these areas, as well as detailed implementation using Micro Integrator and Ballerina Integrator. So that is how the developer experience would look like, because both of them are having VS Code based plugins. So the developers we can easily use it, and both of them look similar. Experience wise, it's similar. So without much effort, whether you are coming from the coding background, whether you are prefer low code stuff, you can use any of those, because it doesn't limit to the visual capabilities only. It has a code view as well. In Ballerina Integrator, underneath source code is in Ballerina programming language. In Micro Integrator, the underneath source code is in the Synapse configuration language. So that's a kind of high-level overview. With that, let me continue with the rest of the session. So in my session, what I'm going to cover is mostly the new stuff that we have introduced with the Ballerina integrator and some stuff related to streaming integrator, and also finally the Devant experience, that is our iPaaS offering. So this is the source code repo in case if you have missed during the first session. This contains step-by-step guides as well as sample applications that we have developed. So have a look at it, and even if you can follow it offline as well. That's kind of a summary of today's session. So I'll give a couple of seconds to load the URL. Okay, so having said that, so I'm going to cover the first part as AI capabilities of the platform, because the current trend is we are looking for AI solutions, or we are looking for AI capabilities to make our lives easy. So then why shouldn't we try that with our development approaches? I think most of us are trying it out with the Copilot and ChatGPT, whatever. We are taking everything. We are trying to take the advantage of all these things, but then that experience might not be that seamless. And also we need first-class support to our products to make sure that it provides the right answers as much as possible. And also the experience-wise, there are multiple stages. The first stage is the development stage. Definitely when we are developing an integration, we need the support to generate it. That's the first part. And then this is kind of a little bit complicated diagram, but usually what we have before the AI era is somewhat from here. We write the source code and then it generates a bytecode, machine code, and it goes to the hardware to execute. But with the AI capabilities, we are trying to simplify the process to come into the source code level. So there can be business related documentation, technical documentation, and source code level comments and other things, which we can utilize effectively to make it an efficient experience or effective experience for the developers. As well as there are some runtime aspects as well. So I'm not going to describe all of these things, but in a summary, we can use AI capabilities in multiple stages. One is the development time, where we can get the assistant kind of a support to develop certain things, and also compile time support. I will showcase that in my tutorial. And also the runtime aspects, where basically we can offload some of the tasks to the LLM so that he can process it. It can process it and give us the answer so that we can use that answer to proceed further with our integrations. So those are the various stages and areas where we can use AI. So before going to these details, let me start with the Ballerina integrator so that we can experience how it looks like. Let me start with the new one. So here I'm going to use the Ballerina integrator plugin. And there I'm going to create a new integration. So let's say I'm going to create a service for an order management service in a typical store, like some shop or something like that. So Chathura covered this part, but anyway, I'm going to create a new project, and I'll save it in my local file location. Let me create a new folder. And this is my integration. So once you get into here, we have two options. One thing is like you can use add construct option here, and it gives you all the capabilities or all the artifacts that we are supporting, and you can build your integration without any issue. I think that is what mostly Chathura followed in his tutorial, without relying much on the AI. So with all these artifact types, we can build our integration. There's no problem with that. But let's see how we can use AI to get more support into that. Basically, make it a little bit more easier to make some of these things, but still we have to use our brain power to adjust it and customize it as we need. So it's not like AI is going to replace everything, all the developers. AI will help us to generate some of these things. So this will open up WSO2 Copilot. It is having some tools integrated already. Let me close this panel so that we can see bigger picture. I'm not sure whether, yeah, I think it should be good enough. Yeah. So it has many tools already to generate and also to give some testing support, data map, and some vertical related stuff related to healthcare. Ask is basically some questions. You can ask some questions, natural programming, and things like that. And also, so in this case, I'm going to start with OpenAPI. I'm asking him to generate me Swagger OpenAPI definition for my service. Create an OpenAPI specification for a store to manage orders. So Copilot will analyze my request and it will give an overview of what are the key capabilities as well as the endpoints that it is going to design for me. And it's taking a little bit to generate the integration. So once it is generated, you can see the OpenAPI YAML file with endpoint details as well as other resources with input-output types. So then we actually have the capability to give an OpenAPI specification and generate the code out of it. That's already something available in Ballerina. So let's offload this capability to OpenAPI AI as well. And let's see how it goes. First of all, let's add this to our integration so that we can keep this file with us. So it's got added to the project. This is the file view. Usually, if you prefer the low-code view, you can do everything without moving to the file view. This is where the low-code view available. But if you are familiar with coding and if you prefer to see what's happening underneath, you can always switch to the code mode and see. But the purpose of Ballerina Integrator is to make sure it's a low-code tool so that even a low-code programmer can use it easily without even looking at the source code files. So this is the low-code view, and let me ask the Copilot to generate the source code for me. So AI, we can't 100% rely on the AI because it depends on the LLM capabilities and other things. So it gives a summary as well as it gives us some suggestions on what to use. Let me ask this to generate. It gives some summary and some problems that he can see. It takes a while because it's connecting to the LLMs and then it's giving the suggestions. Always, it is organizing the generated code into multiple files.
Hoping to ask a quick question while it's generating. You mentioned the LLMs and how it needs to connect to them. Is it sending your data anywhere to train the LLMs?
Yes. So what we are doing underneath is we take the prompt and we do some prompt engineering part to make sure that it is catered to the Ballerina. We attach some of the context and associated knowledge to that as part of the context, and then we send it to the LLMs. So this is the default. You can configure it as well. We are connecting, I already logged in, which is WSO2 Copilot. So we are using multiple models underneath. It's not just one model to optimize the behavior. before using this feature, you need to log into that. And it's free to use. We are not charging any as of now. And also, if you have GitHub Copilot already, if you have purchased it, you can authorize it to give you the suggestions in the low code, not just the code suggestions as usual GitHub Copilot is doing. If you enable it in the Ballerina integrator, it will give you the suggestions in the flow diagram as well.
Okay. If we are using the WSO2 Copilot, does that mean it might be using our like proprietary data to train the model though?
Yeah.
Okay.
Yeah. So it is kind of, we are using a combination of the models right now, and we can't specify one specific model because we are optimizing here and there to make it more effective for the Ballerina language underneath.
Makes sense.
Hope that I answered the question. So I think now it has done the job. Let's see. Yeah. So now you can see it has generated 2 files. One contains the types as per the OpenAPI specification. The other contains the source code. So after reviewing this, we can go back and forth asking to fine-tune some details if we need. But just to save the time, I feel like this is correct. And then we can add it to the integration. So once we do that, you can see the diagram got generated. And still you can edit anything from here. This is the usual flow that we discussed previously. You can see either low code view or code view and adjust or edit accordingly. And for example, here when you click it, you can use the usual palette to add constructs at any place. So that is a generated code. And now the next thing is how we can generate tests, something that is very painful in usual scenarios because we have to cover test for all these things, and we already have the use case in hand. We know the exact OpenAPI specification, so writing tests are kind of straightforward, but at the same time time-consuming. So we have this tool in the API WSO2 Copilot where you can generate tests. So it has some prompts already inbuilt. That is to generate test for the service. You can mention the service which we are going to generate the test. For example, here the service name is V1. This is the service name which has multiple resources. So we can mention that service. Once we do that, if you just go to the file view, you can see the generated test code. So actually this file contains some errors. Sometimes LLM can result in some erroneous code. For example, for simplicity, let me comment it out for now, or return an empty string for now, just to demonstrate. We always have to check what is actually happening or what is the actual code generated, because we can't totally rely on AI. That's the current status of AI, and with the advancements of the LLMs, hopefully in future we should be able to do or rely more on the LLMs. So it is generating the test plan. So we can review and go back and forth to refine it. It is giving the full test plan with multiple scenarios, and finally it is generating the test for the service. Once it is done, the test will get added to the project. We can actually add, we can pick and add, and then it will be part of the project and we can edit as needed. So while it is generating the test, we can explore a little bit the generated diagram. Actually, it's the same thing, same overview, because at the end of the day, it's generating a Ballerina source code underneath, and the VS Code plugin is capable of generating the diagrams and everything as usual for the integration. So this is the test file. Okay, thank you. So this is the generated test file. it contains the test cases as per the generated test plan. After reviewing it, if you are happy with the generated plan, we can add it to the integration. So you can see now the test folder is added with the test.bal, where we can edit if needed, or add extra validations if we need. So that is kind of development type help that we are providing. So it will simplify part of it and still can't replace the entire thing. So we have to validate and add it to our projects. So then, so if I go to the next part, let me open up the VS Code, GitHub plugin repo as well. So we covered the use case 2 on how to use Copilot. So let's go to the second part, that is about natural programming. The first thing that we did is to get the support of AI to develop some of the things for us. Now let's see how we can use our natural language to generate some prompts and generate code then and there as needed. So there are multiple ways to do that. So let me start with some example here also. So I'm going to start a new window. And because it's much easy if we start with a new one so that the idea is clear. Otherwise, we can use the same thing in the same project if we are developing one integration. Let's say it's natural, since it's a demo about natural programming, I'm just using it. You can select a path to save your integration. And once you create the integration, you will see the same via your view, where we can generate with AI. So far we used few commands out of it. Actually, the normal prompt is by default the generate, where we can simply type, or if you say generate, it will do the same. And we use the test command, and we use the OpenAPI tool. So the next one that I'm going to use is natural programming. So let me zoom it a little bit. So in this natural programming, the scenario is a little bit different. So let's say we have a set of business requirements, which is in the form of documentations, or it comes in various forms. So right now we support the documentation or text format. The scenario is like, let's say we get some requirements set from a business analyst to implement. So that means we don't have exact idea. It's not an OpenAPI specification which is to the point. It's a business level requirement that we are getting. So then how we can think of the entire user experience if you are getting such a set of requirements, and how we can evolve such a project using this set of requirements. Because one-time generation is we can use all the time using the generate command, but it's not only about that. When we get some requirement in a real world project, we have to think about the maintainability of the product implementation, as well as how we can accommodate the changes, adjustments, how we can keep track of the adjustments if we have done some decisions in between. Likewise, in the real world, just generate and forget will not work, because we need to keep some connection between the incoming requirements which are coming as high-level business documents, and also we need to make sure we maintain the developer level changes that we are doing in a way without losing this chat history, because this chat history is always we can lose, so that it should be something beyond that in a long-term project. So what we can do is we can generate the code based on the requirements. So what kind of requirements we can provide. Here I'm giving a sample. So it's again for the order management platform, but in a kind of very high level business level requirement, it is explaining what the system would do. So I'm copying that. It can come in a file as well. We can save it in a file and give the file. Here I'm giving it just the raw format of it, and I asked the natural programming to implement that requirement. the prompt is generate the code based on the requirements. So it's taking a bit of time as previous case to generate the things. So here what we are trying to fill is the gap between the developers as well as the business requirements which are coming from business analysts and so on. So here you can see the default set of files that we get in a typical Ballerina project. If you prefer to the low-code view, you don't need to look into the files, but in this case, I'm opening up the files to show you how it will get added to the project eventually. So it is created, it has created multiple files, and we can review and adjust as needed. But in this case, adding it to the integration. So now you see, we got another folder called natural programming. In this, let me see. So you can see the developer.md file here. So that is actually to keep track of what are the changes that developer is suggesting on top of it. So here there are some red color warnings, maybe, yeah, due to imports. It takes a little bit time to import some of these libraries, and it got resolved with time. And this developer.md is that if you are customizing some of these things, let's say after we evaluate the code, or go through the code, if we decide to change something here, then we can suggest those changes within this project. For example, let's say the requirement has sorry. Let's say we want to change this to store in it is storing in the in-memory table. Let's ask the system to change it to MySQL database. Let's see whether that will work. Change the data store to MySQL. So it will analyze the request and the requirements, and then it will adjust the code based on the new requirement, new request. So instead of the in-memory table, hopefully it will use the MySQL. So it is giving the SQL scripts and other things which we can customize and use. It has generated the configurations and everything. Let me add it to the project. So now the code is got added, like we change it to the MySQL, and the change that I wanted to show here is the developer MD file. It contains, or it acts like a log file, which records various events or various prompts, summary of the prompts given by the developer. So with the time, this will get, the log lines will appended, and whenever the developer asks to do certain changes to the code, this will get stored in the developer.md. So eventually, if you start with the requirement files here within this folder. You can see your requirements are here. We generated the source code based on those requirements. And these are the developer level changes that they have made on top of the given set of requirements. Those are kind of technical requirements that we have changed. So with the time, when someone comes into the project as a new person who is going to be the developer, then he can see the set of requirements and he can see how the changes happen. So if, let's say, we change the logic a little bit here. So the one requirement in this use case is to send a order status mail. Let's say for some reason we removed this one, or someone accidentally removed it, or someone purposely removed it thinking that, okay, we don't need to send an email. In that case, how can we make sure our requirements are still aligning with the project implementation? So there's a help for that as well. We can ask the natural programming prompt to check the drift between the code and the documentation. So that is to make sure we are still aligning the original requirements, although developers have made some comments in between. So it will analyze the requirements again and see if the already available code base is adhering to those set of requirements. So that is useful when we think about the long-term maintainability of the project, and we can improve certain things here, but this is at the current stage, we can see whether these are adhering to the code and the documentation. So this means includes API docs and many other things. So that's the diagram that I showed earlier in the slides that we are trying to fill the gap. So if I go back to here, so this is the gap that we are trying to fill here. So usually we start from the source code by reading the requirements, specifications and other things. But if we can bring in these business requirements, technical documentations, including API docs and those kind of things, and if we can make sure everything is tied together, and if the underlying AI model can understand the relationship between those things, then definitely it will help us for the long-term maintainability of the project. So right now it's saying no drift for some reason. Yeah, anyway, so the idea is it will give you some warnings when you try to use this command. So eventually we can maintain the parity between the source code as well as the requirement documents. So that is one part of the AI implementation. And then the next part is how we can use natural language to use coding. Instead of writing things as source code, what if we write things in this kind of a syntax, so that we can ask the underlying AI models to either generate code for us. We have two options actually. We can write this in this kind of a prompt, natural language, and then we can ask the underlying AI model to help us to generate the underlying Ballerina code. That's an option one. Or else we can pass this into the model so that we don't generate underneath code, and it will give us the results back so that we can continue with those results. So I will showcase that part. Basically, we are using a prompt. We are sending that prompt to the runtime and AI model, and it will give us a result and how we are going to use it in our integration flow. So in this scenario, I am going to start it as a new project to make it simple. That is what we call natural functions. So if we create a new integration, we can see natural functions. And let's save it. This is the same integration creation flow. So here again, instead of generate with AI, now I'm going ahead with the construct that we already have, that is called natural function. So creating a natural function, let's say I want to know I want to hand over some tasks to LLM. Sometimes we can't do everything in our code base. For example, if we want to do some detailed analysis of something, or else if we want to grab some data after doing some analysis. So in those cases, we need to make sure instead of we are doing it by ourselves, we can hand over that task to the LLM. So what we can do is, let's say I want to find out most popular person who was born in a given year with some part of given, let's say, most popular person who has a name as John or Peter or something and born in a given year. So we can't write the code for it because we don't know how to write a code for such a thing. We need some knowledge associated with that. So let's pass that task to the LLM. And it's like a normal function. So let's create a name for the function. Find most popular person. And as a parameters, what I'm giving is name of part of name. And it is a type of string. And then the year. So these are the two parameters. And the return type, let's say I want some details, not just the name. Let's say I want to create a type called person with some information like name, country, and year of birth should be the one that we are giving as the input, but just in case, let's add that as well. So it created a new type called person, and I'm going to use it for this function. So this is the function. This looks like a normal function, but the body of the function is something different. It's not a usual source code or usual flow diagram. We are just going to write a prompt here. So what I'm going to write as a prompt is return the most popular person who was born in the given year of, we can refer to the variables here, function input parameters. So this is my function body, unlike a usual function. So now it's like a normal function. If we don't worry about the body part, it acts like a normal function. Then how we are going to use it? Let's go back and let's create either service or automation or something else which we can use this function. Just to save the time, I'm using automation. Automation is like normal main function which we can run manually or periodically. So let's create automation, and we can call this natural function from that automation, and the return variable type name is given as person. Let's try some random name here. Birth year, let's say 1976, and let's add a log here. Instead of log, I will add a print so that I can print everything in one go. So now everything seems good, and I can run this one. So it will send a call to the LLM because this function is not a normal function. And it gives an error saying default model is not initialized. That means because we need to contact LLM and you need API keys and other things. And the good news is like we are having LLM model underneath which we can use for these kind of things. So we can configure it to use in this scenario as well. Configure the default model for natural functions. And then let's rerun it. It's giving some error. Maybe something to do with the prompt. I'm not sure whether that will work. Let's see. It depends on the prompt sometimes. And that is an undeterministic nature of the AI. So if we hand over such a lot, definitely to LLM, we have to rely on the response from the LLM because we don't have any response here on what LLM can do. Any control over what LLM can do. So this time, once I changed the prompt, it gave a different answer. I'm not sure whether this one, someone that you are aware of. So somehow that's what LLM says. So he was born in this year and the name of this person having part of John. So that is the natural function behavior. So that covers a different aspect. It's not about the development time. It is about how we hand over some part of the code as prompt to the LLM, either to generate the results and give us the result, or else use it as intermediary thing which can generate the intermediate code. So that covers the natural programming and some part of the AI capabilities. Actually, this is just a summary of some of the capabilities because I covered only Ballerina integrator here. And there are many such AI capabilities in Ballerina integrator as well as a micro integrator. And in all our documentation, we have all the details. One last thing that I want to cover is developing AI agent. So that is a different story altogether because AI agent is something that we can use to act as an assistant for us. So let's say, let me see whether I can find already implemented one to save my time. Okay. So this is kind of AI agent. So let me, since now we are familiar with the constructs and other things, I will not go step by step. So this is also created in the same way like we created the other things. If you go to add artifact, we can see AI chat agent. So this is another artifact type we can add. So the difference between that and the normal functions is like, this is the actual view of the AI agent. We can configure the AI agent by giving a prompt. So the prompt that I gave here is like act as an AI assistant to help the calendar management. Let me zoom up a little bit. Email assistance, those kind of things, and response to certain events. So this agent you can see multiple tools associated with that, and also the model. So with this non-dotted line, we can see the model. There you can configure the model that you want. So we are not providing our default models here. So you can select whatever the models that you already have and select that model, and you can configure it as you with the keys and other parameters. And then you can associate various functions to use as tools for this model to complete this task. So these models might use or not use based on the prompt. That's why there's a dotted line, because if I ask the agent just to create a calendar event, it will not use the email capabilities. But in case, since it is acting as an agent, in case the prompt has something to do with both emails and calendars, then some combination of these tools will get used. So let's see how we can use it. So all these things, even these tools we can add here. These are the already added tools. How we can add a new tool, it's also easy. One thing is, like, if you are talking with some other client like Gmail, Calendar, we can first add the client. You can select from the various or large set of available clients to include with this agent. And then you can, once you select the to connection client, you can pick a function out of these available list. Then once you add it, it will add as a tool to the agent. So the send mail, receive mail, read mail, create calendar, those are the kind of tools that I picked out of these existing functionalities. Now let's see how we can run it. Before run it, I need to configure it. So I already added config.toml with my keys in the file. Let's try to run it and see what we can do with that. So it's running. With that, we have a chat embedded to interact with. Let's say hi. Yes, so this AI agent is actually exposing a port. So this chat agent window is written in a way that it can connect to that port. And this is the chat request. This is the prompt, which is getting as a request to this agent. So now I can ask to do certain things. Can you send a mail to my other email address? Let's say Anupama@WSO2.com with the subject WSO2Con. Content, what to include? Let's say, please welcome to the Let's see whether I got it. I just need to open up my emails and see. There are tons of emails. Sorry about it. Yes, we just got it. The agent sent it on behalf of me. Similar to that, we can create calendar events, schedule things, and do certain things based on the email, because the tools are already associated. So we can ask prompts like, read my latest email with a calendar invite and give me a summary of such a thing. Likewise. So we can attach many tools as needed based on the use case. Actually, the tricky part here is to write the prompt on what to do and select the required tool set or the right tool set for your agent. So once you have such an agent, we can embed that agent into various flows in our integration. So this chat window is just another embedding that we can use in the development time. But let's say if you want to embed it into one of your services or anything like that, we can add agents as needed. So AI agent is something that we can embed. So that's about the AI capabilities. Any questions so far? And some stuff that I didn't cover is like micro integrator AI agent, AI capabilities. That also includes agent capabilities and things like that, completions, all these things, Copilot support. All these things are in micro integrator as well. And also data mapping support. In both Ballerina integrator and micro integrator, we have data mapper support, which handles the auto mapping features. If you have a complex data mapping, it will help you to add a construct with a data mapper. And you can use the AI to map to a certain extent. I think we had a question in the previous session as well, whether we can use AI to map the data and so on. I'm not going to use it to save the time, but what happens is like it will analyze the incoming input payload as well as output payload, one or the other, one or many, and then map accordingly. And also we can edit as needed, and we can add expressions in between to adjust the behavior. So with that, we are reaching to the end of the first part. Let me quickly go to the second area that I want to cover. That is about streaming integrator. A bit of capabilities of streaming integrator. Let me quickly give some overview, because streaming integrator is not a new product. It's not a new offering. It's a part of the WSO2 products for a long time. And now we are revamping it and we are offering it as a WSO2 Integrator product offering. So if you are not familiar with that, it's basically it's capable of reading a set of events or streams in real-time manner, and we can extract data out of those events, and we can analyze it, do some query process. We have a query processing engine, which is what we call Siddhi. It is also owned by WSO2. It's a stream processing engine, and there's associated query language where we can query the streams for certain events or certain aggregations or certain windows, and then do those operations, get the insights out of those incoming streams, and write it down to the output stream. So we can combine multiple input streams, output streams, one or many. So it's very useful for scenarios which include sensors or some things which generate real-time data events, and to analyze those and write the summary or whatever the output to the other data sources. So that kind of, if you have such a requirement in your integration, we can include streaming integrator. So it's part of the WSO2 integrator. So it is seamlessly connecting with control plane and so on. That means you can consider it as part of the entire integration story. There I'm not going to the details, but I'm showing you the integration developer capabilities with little bit of one single scenario, so that you can get an idea on how to do it or what kind of things we can do. So the scenario that I'm going to use it, simple fraud detection use case. Let's say if the certain set of transactions in a bank transfer or something exceeds a certain value, let's say 10,000, within if a given user has more transactions or many transactions which are exceeding 10,000 within the given window, let's say 10 seconds, then we need to detect it as an anomaly. So let's see how we can analyze or write a integration or write a streaming query to handle such a thing. So to do that, I am using WSO2 Streaming Integrator. Actually, to showcase the developer aspects, I am using the integration tooling. It has a built-in runtime as well, so that within the tool we can run it. Let's see how we can do it. So the first step is we need a set of, since let's say the transactions are appearing in the database, so we need to extract or capture the data changes in the database and take those out or detect those, and then see whether there's a threshold, if they are exceeding the threshold, and then generate the emails and something like that. So to handle that use case, we need to use a source. That source is the database, and change data capture, we are detecting the new rows which are getting added to the database. And then this streaming engine is analyzing based on the criteria more than 10,000 within 10 seconds. So that criteria, after it is analyzed, we can send it out to the files or some email saying there's an anomaly. That's the scenario. So first, let me configure the database. To do that, I will use the DB script I added here. I have a locally installed MySQL database. It's already logged in. Let me execute this script. So I added some initial rows just to make it common. And that is my data source. Now let's configure the source. So to configure the source, we need to add the database driver so that streaming integrator will detect automatically there's a source as a database. So what we simply have to do is copy this database driver into the library folder. So this is I have my driver already downloaded here. This is the tooling folder, zip file. So let me go there. So I'm going to copy the MySQL jar file to the lib folder. So once it is added, what we have to do is we have to change the deployment YAML file to include these configurations. That includes source. This is the sink and source. Source means from where we are capturing the input. So in our case, it's change data capture in the database. So we need to configure the username and password of the database. And the sink is where we send out the output stream. In my case, I'm trying to send a mail if there are some anomalies. So I need to configure the properties related to the email. So I have already configured those things in this deployment YAML file. So I will copy that into the conf server folder. It already has a deployment file, it will replace it. So now it's configured, source and sink configured. Let's try to run it. So this is actually in the development mode. So that's why it's named as tooling. Otherwise, you can directly deploy it into the streaming integrator server as well. Once you define the streaming query and other things, this is the editor that you can use to develop your streaming queries and streaming application. So I'm going to create a new application here. So let me copy and explain it a little bit. This is my Siddhi application. So it contains the same stuff with the source and the database URL, and it's taking the other configurations from the deployment configuration, and these are the email details and the subject of the email that I'm going to send. And this is the query part. From the transaction stream, with the window of time 10 seconds, I'm checking whether actually it's increasing 100,000 in that given time period. So this is my streaming application. Let's save it with some name, transaction anomaly. Once we have that, let's run it. You can take this Siddhi file into the streaming server as well, and you can deploy in the server directly. This is the tooling where you can try it out. So it started, And now let's try to add some transactions to the database. Let me add a few rows to the database. Hopefully it should send a mail as that is what it is configured. I added 3 rows. So it says emails, it is logging some email events. Let's see whether I got a mail. Yeah, so I got a mail 0 minutes ago with the topic suspicious transaction detected. So that is a very simple scenario of streaming integrator, where we can use it for various input streams, as well as we can customize it to handle many different sync or output streams as well. So that is one component of our WSO2 Integrator product offering. So now we are coming to the last part. So let me go back to our slide deck where we discussed various components. In a summary, these are the components: Micro Integrator, Ballerina Integrator. You can pick and choose and you can design your integration flow. Streaming Integrator is catering a different part of the problem with events. And integration control plane is, we didn't cover it in a demo, but it's not that complex. It's a simple thing which can connect to each of these things and give one single monitoring dashboard kind of thing for your services, where you can see how many services are active, how many services are running. You can enable, disable logs, those kind of functionalities. And the last thing is how we are going to deploy it. So WSO2 Devant is a new latest offering, which is the low-code AI iPaaS, where you can deploy these artifacts into the Devant. So let's see how we can do it. To do that, let me go log into the Devant console. You can access it using console.devant.dev. So typical user journey in the development life cycle is we write some integration in terms of code or using whatever the mechanisms, using the code or flow diagrams, whatever. Then we save it in a source code repository. So we start the deployment part from there. If you already have a developed source code in a GitHub repository, you can bring it here. Or else, if you are using VS Code and let's say you want to publish it into Devant, you can use this deploy option as well. So we have seamless connection between the editor as well as Devant. Once you click it, it asks what is the type of the artifact and then which organization you need to publish, some details like that. And eventually it will come here. So in this demo, I'm going to use existing sample. Let me go to my GitHub repository. So you can link any of your repositories. Until it's loading. I think network is a little bit slow here. So you can see this is very familiar user interface if you are already using WSO2 Choreo, because underneath the platform is Choreo. So it's well tested, heavily used platform. So what we are providing here is the iPaaS offering, which is built on top of Choreo. Only for the iPaaS means we are using it for the integration use cases. So we are optimized the generic Choreo platform to cater the integration scenarios. So here the first step is attaching a repository. I just wanted to show my repository. Okay. It's very simple service, order service with one file, actually very, very simple service written in Ballerina. So if you developed the code using Ballerina Integrator, you can come here once you commit the code, or you can simply use the VS Code editor itself to come into this place by committing. So I need to authorize with GitHub because my repo is in GitHub, or you can use whatever the source code platform you are using like GitLab. and then at the repository. Here you can select the service. The repository is already appearing because I used it before, but if it is a new repository, you can use the connect more repositories option and authorize in the GitHub side to allow it to get it added here. And once you are done with that, you can select the path and other details. Since I am in the root folder, I don't have to select the path. And then I have to select the technology. So since the code is already there, it detected it as a Ballerina integrator because the code is written in Ballerina. So if you start with the empty repo and then you develop the use case, you can select either of these things and then develop your integration based on the selection, and then come back and push the source code to the GitHub through the VS Code plugin, and it will appear here. So you can do incremental developments. Let's see how we can deploy here. So Ballerina integrator, and the artifact or the integration type here is a service, because my source code is a service. It's not an automation, which is a usual main file function, and it has the capabilities for AI agents. Because we treat AI agents as special case here, it gives more additional capabilities to integrate and deploy your agentic flows, and also event integrations and file integrations. Since this is an API, I am adding it here. Once we create that, it takes a little bit of time because it do some work in the background to make our deployment available. So all this experience is very much streamlined with the WSO2 Devant, WSO2 Choreo, and WSO2 Vijira, our latest API management platform. So you will see very, very common user interfaces here. So to make it very simple, we have an overview page where you can see the repo name and the details when it is added, things like that, and you can open in the VS Code from here as well. So you can see this status here. First it is setting up the environment and do certain checks after checking out the code, and then also certain since we selected the Ballerina as a technology, it's doing a Ballerina build underneath, Ballerina source build. So it's currently in progress. Once it is available, you can see the various deployment environments. It can be development, production, and even you can add more environments if you need, like QA or some intermediate environments. Once the build is successful, we can test it in the deployment environment. Now the build is completed. You can see the build logs if you want. And this is deployed in the development environment. Let's try it out in the test environment. That is our development environment. It's like Swagger-like view. We can simply try it out. You can see the response. So there are two resources. I'm not going to invoke the other one. So once you are happy or the test is done with the development environment, you can promote it to the production environment. So this is the promote button here. So if you have any configuration variables in your application, where sometimes we pass API keys and things like that, you can configure it here. Since my application doesn't have anything, I can proceed. This option, whether it is asking whether to use default configurations given in the code, or else use the same configurations used in the development environment. Now we are continuing with the deployment. It gives a summary of the endpoint, what port, what is, where it is getting deployed, the name of the source, context, and other things. Once we promote it, you will be able to see it in the production environment. So now it's in the production environment. Now we can't test it like here in the production environment. It's restricted. You can configure it there later as well if you have any configuration variables in your application. So this is very high level overview of your integration. So without much effort, it's like zero effort. You can bring your integrations into the production level with this Devant. So it's simplified the entire process. You can see the summary and everything here. And this side panel also contains the same thing. You can go and see how the builds are happening. If there are multiple commits, you can build certain commits only and build those things. Sometimes we need certain versions in QA environments, certain versions in dev environments, like that. So once we are done with testing or various checks, we can bring those versions into various environments. So these are the environments I have, development and production. So right now it's the same commit that I have in the both environments, but we can pick and choose what commit that we are going to bring here. So if I have multiple commits, they all will list down here. I can pick which commit to select and promote. Likewise, all the additional capabilities are here and we can configure. You can think about the deployment aspects and you can see the insights as well. So let's say test. If we didn't try out in the production environment, in the test window, we can try it out in the production environment as well. So this is like your real production environment once you deploy your application. So I executed it multiple times, and you can also see observability. Under observability, you can see the various logs if your application is logging something, and API insights. API insights have multiple things, which include some high-level overview about number of integrations and active integrations and those kind of things, and DORA metrics, which is very much helpful for the product management side. How many deployments, what's the deployment frequency, how much time it's taking for the deployment, things like that. And also some business insights, the traffic details, latency, and all those things. So those details views are available. But once you go to the overview section, you can see the details as well. All these capabilities are available. So one thing, these are I added 6 requests to the production and 1 to the development. So all these things are organized in the project, within a project. So you can use the default project comes with the demand. So if you are simply having one team developing a set of integrations, you can go ahead with the single project. But if you have very complex business units which are deploying various projects independently, you can consider having many projects in your organization. So this organization is like your own organization. For example, these are my personal organizations, but you can create one organization for your company. And then within that, you can have multiple projects for each business unit, or whatever the appropriate logical or separations. And within that, you can deploy your integrations. So within one project, we can have multiple integrations, and you can have many projects as well. So with that, there are some other features like architecture diagrams and so on, which is more meaningful when you have more services, how they are interacting with each other, how the traffic comes in, what is the weight of the traffic, what are the high frequent services, those kind of details you can see here. So that is kind of one easy stop to deploy all your integrations. So with that, we are finishing off the tutorial as we covered most of the aspects of the WSO2 Integrator. And if you have any questions, feel free to ask from us. And yeah.
I was in a talk earlier today, and they covered Oreo.
Yeah.
Very like this was kind of discussed in the sort of context of AI.
Hey, there he goes. So in the discussions, this tool, Devant, was kind of discussed with the context of AI.
Yeah.
What you just deployed was not an AI-based app, so it can handle any deployment that's not necessarily just for AI.
Yeah, that's true.
So what's the I guess if I have both of these tools, am I only using this if I have AI? Like the Choreo wouldn't support deploying these AI-based applications?
No, it's not like that. Actually, Choreo is an internal developer platform. So let me explain the difference between this and that. So it's a good question that you ask, because if you see the Choreo, definitely you will get the question, why do we need another one? Because we can do all the things in Choreo. It's not that Choreo can't deploy any agent applications or AI applications. It can. It is what we pitch it as an internal developer platform that can host anything. It can be a web application, backend application, written in many languages. It can be Java, Ballerina, .NET, Go, Python, whatever. And it is covering a wider spectrum. So this is highly focused on the micro integrator, Ballerina integrator, the integration offerings. You can't select any other options here. This is to make sure the developer or the team's lives easy. When they have so many options, sometimes it's not that easy, and it has all the deployment complexities. You can configure everything, not complexities actually. Choreo is hiding the complexity, but at the same time, it has more capabilities. But here it is restricted for the integration scenarios, and we can't deploy web application types here. It's integration either as automations or as APIs or file integrations we can deploy, but not all the other types of the artifacts. So we can deploy AI or non-AI applications which are related to integration, and also technology-wise it is limited. It's only Ballerina and Micro Integrator.
So it's a subset. So it's really just there to focus on people who are maybe just developing in Ballerina and don't have any intention to do anything else.
Exactly.
All right.
So if you have wider requirements in your organizations to develop and deploy various kind of applications, definitely you can go for Choreo with all the capabilities. And there are certain companies, they are highly focused on integrations problems and they just want to deploy integration scenarios or applications, then they can simply go with this without extra complexity with Choreo. It is not that Choreo is complex, but it has more capabilities. Any other questions? I think it's all good, and we are almost 5 o'clock. So if you have any questions, feel free to meet our team at Oxygen Bar as well as outside tomorrow and day after tomorrow. And we are happy to answer. Thank you for staying with us for the tutorial.